In our previous videos, we have discussed about what is meant by radar cross-section. So you may be wondering why there is a particular session or video on antenna RCS. Because when we consider the antenna RCS, it is little bit tricky and fascinating. Let's consider a flat metal plate, and when we are hitting the metal plate with a radar beam, it will scatter the waves based on its properties, right? But in case of antenna, it is a specially designed structures in order to transmit or receive the electromagnetic waves. So when a wave is incidenting on this antenna, it will behave differently rather than just a reflection. So different things means in particular two different types of reflections will be happening from the antenna, which will be contributing for the radar cross section. So in this video we can see what these are. So we know what is meant by radar cross-section. Radar cross-section actually measures the detectability of an object when an electromagnetic wave is incident on it. And this is the definition of the RCS. So sigma is given by limit r tends to infinity 4 pi r square es square by ei square, where r is the distance of separation between the source and the target, and es is the scattered wave electric field, and EA is the incident electric field. So to get more idea about the radar cross section, we have a video on our channel. Kindly watch that. So in this video, we are going to consider an antenna. So let's consider a microstrip patch antenna like this. So this is the front view. Here you can see that this is the antenna which is made up of the metal, and it has a dielectric and which is also backed by the metal plate. So let's first consider that this antenna is not fed by any electromagnetic wave, or it is not connected to any receiver or transmitter system. So let's first consider when a wave is incident on this antenna like this, based on the properties of the structure like metals, dielectric, and the ground plane, there will be waves reflecting from this structure. So this type of scattering is mainly because of the physical shape and material of the antenna. So it usually contributed from the structural property and the material property of this antenna. And this type of scattering is known as structural mode scattering. So for all of the structures, we are mainly considering structural mode scattering or structural mode RCS, which is mainly due to the material properties and the dimensions, shape of the structures. But in case of an antenna, these antennas are specially designed structures to transmit or receive electromagnetic wave. So let's consider if this antenna is connected to a receiver system. This structure will be providing another sort of RCS. So let's see what is mean by that RCS. So an antenna can provide structural mode scattering along with another sort of reflection when this antenna is connected to a receiver system. So let's get into more details about that. So let's consider when an electromagnetic wave is incident on this antenna. So based on the structural properties, there will be a reflection which correspond to structural mode RCS. But means as this antenna is in receiving mode, if the frequency of this electromagnetic wave is matching to that of antenna resonance, this antenna will be receiving this electromagnetic wave, right? And as it is connected to the receiver, these waves will be transmitted through this antenna to the receiver system. So let's assume that this receiver and this antenna are not matched. So in that case, due to the impedance mismatch between these antennas and the load, there will be some reflection back. So here you can see that due to the impedance mismatch, there is some reflection back to the antenna from the receiver system, and this will cause the radiations from the antenna. So this re-radiation or the reflection from the antenna can cause another type of RCS, and this is due to the antenna mode of operation. So this scattering is known as the antenna mode scattering. So if you are considering an antenna, it can provide two types of reflection. One is mainly based on the structural mode, and second one is mainly due to the antenna mode because of the impedance mismatch between the antenna and the receiver systems. So this is the main route for the antenna mode RCS. So this will be due to the impedance mismatch between the antenna and the load, which is causing the re-radiation from the antenna. That is, the main contributor for the antenna mode scattering is impedance mismatch. So we can say that this is the workflow of antenna mode scattering. So when the electromagnetic wave hit on the antenna, it will receive that electromagnetic wave and it will be passing to the receiver, and based on the impedance mismatch there will be reflection from the antenna and it will be again re-radiated from this antenna. So this is the workflow for the antenna mode RCS. So let's see what is the total RCS from the antenna. So the total RCS from the antenna will be because of the structural mode scattering and because of the antenna mode scattering. So the sigma total, that is the total RCS, is equal to the square root of sigma structural plus sigma antenna e raised to j5 by j5 the whole square, where this phi is the phase difference between the structural mode scattering and the antenna mode scattering. So let's see the importance of this phase difference between the structural mode and antenna mode scattering. So if the phase difference between this structural mode and antenna mode scattering is 180-degree, this can cause the destructive interference. Here you can see that there won't be any uh, ineffective RCS from the structure. But let's consider the case when the phase difference between the wave 1 and wave 2 are like in phase, it can cause the constructive interference. So the phase difference between the antenna and structural RCS has very important to decide whether the antenna mode scattering will enhance the structural mode scattering or it will decrease the structural mode scattering effect. So let's consider, because when we are designing an antenna, we are designing the antenna to be completely matched to the receiver system. That is, we are making sure that the impedance mismatch is very low when we are designing an antenna. So in that case, we know that when the antenna receives an electromagnetic wave, it will be passed through the receiver, and the receiver and the antenna is completely matched. There won't be any reflection back. So in that case, there won't be any re-radiation from the antenna, and in that case, antenna mode RCS become negligible. So if the antenna is completely matched to the receiver, we can say that the antenna mode RCS is very negligible, and the main contributor will be only the structural mode scattering or the structural mode RCS. So if the antenna is completely matched to the receiver, when we are considering the antenna RCS, it will be simply like a structure which will be contributing for the RCS. So I hope you get some idea about what is meant by antenna RCS and why this reflection is contributing to the RCS, and in case of a completely matched antenna, why we have to consider only the structural mode scattering. Thank you for listening. If you find any of our videos useful, kindly like, comment, share and subscribe. Thank you.